8.3 Geometric Sequences and Series. So what we want to do is we want to find the sum of the first 11 terms of the geometric sequence shown below. So the first term in this sequence, A1, is 2. You can see right there. And to find the R value, we would take the second term right here, 6, and we would divide it by the first term, which is a 2. 6 divided by 2 is 3. You could also, double check that by saying 18 divided by the previous term, 6. All right, that would still give you a 3. So that is confirmed that R is in fact equal to 3. So there's a formula for the sum of geometric sequence, right? So the sum of the first n terms of a geometric sequence is equal to S. So it's A1 times 1 minus R to the n over 1 minus R. Okay, so let's make sure we have all the pieces. We have our A1, we have our R, we have our N, which in this case is an 11, so I guess I should write that down as well. Looking for the sum of the first 11. And we have an R again in the bottom, so we are good. We have all the pieces. Okay, so let's plug it in. So we're looking for the 11th term in the sequence. So A1 is A2 times 1 minus R, R being 3, to the n power, n is 11, all over 1 minus R, R being 3. So what we would have is 2 times 1 minus 3 to the 11th power, which is 177,147, all over 1 minus 3. So we have 2 times 1 minus 177,147, which would give you negative 146, all over 1 minus 2, which is a negative 2. So the 2 and the 2 cancel out. We'll end up with a negative 177,146, all over a negative 1. They canceled out. The 2 divided by negative 2 is a negative 1. So what we end up with is positive 177,146. Okay, let's try the next one. So we want to find the sum of the first 15 terms of the geometric sequence shown below. Okay, so we use the same general formula. So we have the sum n is equal to, I'm just going to use this again, just rewrite it. So we just have first term in the sequence multiplied by 1 minus R to the n, all over 1 minus R. Let me plug everything in. So we need A1. So A1 is equal to negative 5 halves. We need an R. R is going to be equal to 5 divided by negative 5 halves, which is the same as 5 over 1 multiplied by 2 over 5, and this is negative. Cancel, cancel. Let's look at negative 2. If you find the fraction, this and this, to be bad ones to use, you can use any two consecutive numbers within this series to figure it out. So for instance, it might be more intuitive to say R is equal to 20 divided by negative 10, which is obviously negative 2. So that might be easier to use some of the other ones within this instead of a fraction. Okay, so we got our R. We have our first term within the sequence, and we need n. They want the 15th term, so our n is equal to 15. So we end up with S15 is equal to A1, which in this case is negative 5 halves, times 1 minus R, which is negative 2 to the 15th power, all over 1 minus R, which is negative 2. So we keep the negative 5 halves, and we say 1 minus negative 2 to the 15th power, which is a negative to a 15th power. A negative to an odd power is a negative, so it's going to be a negative 32,768. And then 1 minus negative 2 is the same as 1 plus 2. Right? So that would give us a 3. So we have negative 5 halves times 1 minus, right? 1 minus a negative 32,768, which is a plus. So we end up with positive 32,769 all over 1 plus 2, which is 3, which is negative 54,615 over 2. So we're going to find the indicated sum using the formula for sum of the first n terms of a geometric sequence. Okay, so we're going to use the same formula. Okay. So the sum is the first term multiplied by parenthesis 1 minus r to the nth power and parenthesis all over 1 minus r. So just like before, we need to find the first term, we need to find the r and the n. So we need to find all those variables. So the first term is equal to what? Well, in this case, it's going to be 4 to the I, where I is equal to 1. So it's simply going to be a 4. So I just plugged it in right there. I plugged a 1 in where the I is. Okay, now second, we also want to know the R. Well, I can figure out what A2 is. So let's say we want to find A2. Well, A2 is 4 to the second power, which is equal to 16. Then we can say 16 divided by 4 is equal to 4. So that's what R is. Or you kind of just look to see that there's the base is 4 right there, and that's going to be your R. But when in doubt, you can just find two consecutive numbers within the sequence and divide the later one by the previous one, and then you'll get your R, which in this case is A4. Okay, now what else are we looking for? Or the n? Well, the n in this case is going to be right there, which is the 7. So we know our n is 7 because we're going to be summing up the first 7 digits. So this right there again, that is my n. Okay, so we have our first term, we have our n, we have our r. So we say s to the 7 is equal to the first term, which is 4, times 1 minus the multiple, which is 4, to the n, which is 7, all over 1 minus r, the r being 4. So we end up with 4 multiplied by 1 minus 4 to the 7th power, which is 16,384. Oops, 84. And that is all over 1 minus 4, which is a negative 3. Okay, so we have 1 minus that is going to be negative 16,383 all over a negative 3, which gives us positive 21,844. So we're going to find the sum of the infinite geometric series. So first of all, whenever we're trying to find the sum of an infinite geometric series, we can only do that if the multiple is less than 1. The absolute value of it is less than 1. So we can only find the sum if R is, let's say R is between -1 and 1. Okay, so what happens if the absolute value is greater than there, it's going to shoot off to infinity, right? But if it's less than, it'll approach some other value. And the formula we use for that is Sn is equal to A1 multiplied by, A1 there we go, which is A1 divided by 1 minus R. Okay, so now in this case, what is our R? Well, our R in this case is 1/2 divided by 1, which is just 1/2, right? So our R is 1/2. So we can, first of all, because of our R is 1/2, which is less than the absolute value of 1, right? So it's R is in between this range right here. We can actually find the sum of an infinite series. Okay, so we want to find the sum. So what we do is we're going to say S, we don't need the n anymore because this is infinite. We're going to put the first term here, which is a 1. And we are going to divide it by 1 minus 1/2. And what that would do is that would give us 1 divided by 1 minus 1/2 is 1/2. Okay, so we have 1 divided by 1/2, which is the same as 1 over 1 divided by 1/2, which is the same as 1 over 1. Well, I'll put the division first. Division by 1/2, right? And if we're dividing a fraction by a fraction, we turn the division into multiplication. And we multiply by the reciprocal, which the reciprocal of 1/2 is 2 over 1. 2 times 1 is 2, 1 times 1 is 1, and 2 divided by 1 is 2. And that's it.